Hi, this is the last video lesson for week 2, and we've made a lot of progress learning about the rock cycle. I want to take you through the slides to review where we've been so far in learning about the rock cycle. So if you recall the project launch day, you got to read an article about how monuments are being destroyed by certain processes and that some of these rock monuments need to be saved. Now, you need to learn a little bit about the rock cycle to understand about certain processes that wear down and break away rock. In the first lesson last week, you read a comic from Mosa Mack. She had to try to solve what kind of a rock she found. There were questions in the echo activity for the comic, and there was an exit ticket to end lesson 1 last week. You may have done this activity, which was the Mosa Mack mind map, showing you the different vocab words associated with the rock cycle. This is actually our first peek at the rock cycle. Now, if you didn't do this and you'd like to go back, it was an optional activity that could be handy for notes for this week's lessons. Now, if you watched the video yesterday or you did the lab at home, the journey of a crayon is really modeling the rock cycle. In science, we often use models to recreate or to mimic a process in science that we can't actually see in real life. In this case, the rock cycle can be really slow and time-consuming. But we could model some of the different processes in the rock cycle by doing the journey of the crayon lab. If you haven't yet got a chance to watch that YouTube video, you can see me doing that rock lab at home. It's really important that you understand the different processes that go into making different kinds of rocks. It's really no different than the processes you modeled during the journey of a crayon lab. So I want to take a minute and talk to you about the rock cycle. Your activity for today is going to be to create your own rock cycle drawing. You can either do that electronically, or you can do that on paper and take a picture and submit. You're also going to need to know a little bit about different types of rocks and the rock cycle to do the lesson 2 exit ticket as well. So let's talk about the different processes that are involved with rock formation. So the first thing you need to know is that no new material is ever created on Earth. We're basically talking about a huge recycling project. Old material is being recycled into something different in every step of the rock cycle. So there are a lot of geological processes at work that are involved in the rock cycle. For instance, plate tectonics, which involve volcanoes and earthquakes. Yep, those make rocks. Weathering and erosion, which is something you may have learned a little bit about on the first day of the project, and something that you may not have known much about involved with the rock cycle, heat and pressure. There is a lot of heat and extreme pressure the farther you go down into the Earth's crust. A lot of really cool metamorphic rocks are made due to heat and pressure. So we basically have two different kinds of forces at work, forces that build and forces that destroy. There are 3 main types of rocks to know. Igneous, sedimentary, and metamorphic rocks are continuously being changed through these different forces in the rock cycle. There are a lot of different pathways, and it never ends. You can use any of these pictures in the next few slides to draw your own rock cycle. It is totally okay to copy them down. You can't copy and paste it into Echo. You need to draw it so that you understand it. No one rock cycle is perfect. There are a lot of different ways to depict these different processes that occur to make different types of rocks. The electronic version is pretty neat. It's actually a Google drawing where you can arrange the different graphics to make a rock cycle. So here's the one that you've seen so far in my slides. This is pretty basic. Igneous rocks are like the original rock. This would be like the crayon before we did anything to it. Now, we can melt igneous rock right back into magma, but when magma cools, it forms an igneous rock. So sometimes they're called original rocks. An igneous rock can be squeezed under tremendous heat and pressure to make a metamorphic rock. An igneous rock, although it is one of the strongest rocks, can still succumb to weathering and erosion. Over time, an igneous rock can be broken down into much smaller bits and pieces called sediments. So a metamorphic rock can also be squeezed under heat and pressure to make a different kind of metamorphic rock. But under enough heat and pressure, a metamorphic rock can eventually melt down into magma. Metamorphic rocks, just like igneous rocks, are still at risk of being weathered and eroded into sediments. So we have a green arrow pointing to sediments here. Now, when sediments get squished over time, we call that compaction, and glued together by different minerals, cementation, a sedimentary rock is formed. Now, don't confuse compaction here with heat and pressure over here. We're talking about a lot more heat and pressure to make a metamorphic rock. We're just talking about layers and layers building up over time. So imagine the layers of the Grand Canyon. That's compaction and cementation to make a sedimentary rock. Now, sedimentary rocks can also be weathered and eroded and broken right back down into sediment. And they can be buried so deep under so many layers that they can succumb to heat and pressure and become a metamorphic rock. So notice arrows going every which way. Now think about these processes as we look at a couple other different pictures of rock cycles. So this one's kind of neat because you can see the surface of the earth. You can see a couple different ways that igneous rocks come to the surface. They can certainly come through volcanic eruptions. And sometimes magma flows into the Earth's crust but never comes to the surface and becomes a hardened ball of igneous rock trapped beneath the surface. But eventually, enough weathering and erosion can expose that. So down here, we have a lot of heat and pressure, and so we find metamorphic rock, pictured here, pretty deep into the Earth's crust, but eventually metamorphic rock can be uplifted to the surface. Weathering and erosion can transport sediments into waterways, and oftentimes many of our sedimentary rocks are formed from layers in riverbeds, lakes, and even oceans. They can become sedimentary rocks, which can become metamorphic rocks, which can be melted back into magma, and the process starts all over again. Now you might be thinking, I just saw that picture. I put this one in because I really liked that it included pictures of what each rock type might look like in terms of grain size and pattern and color. So just a slightly different diagram to take a look at. Now this last one really kind of looks like a cycle. It's got kind of a circular look to it. Not my favorite rock cycle picture, but still just another way to look at it. You can see that all rock types, sedimentary, metamorphic, and igneous, are eventually uplifted to the surface and exposed to weathering. Sediments can be transported and deposited, and the word lithification just means turned into rock. And over time, if they are squeezed and buried deep enough, can become metamorphic, and even more can become melted into magma. And then the process starts all over again. So maybe you like to look at cycles as circles, or maybe you like to look at them with pictures of actual rocks, or maybe keeping it simple is more your style. So for today's activity in Echo, you are going to need to create a picture of the rock cycle. You can do that on paper, or you can use the electronic version that I provided. And you can come to the Zoom meeting on Thursday at 11:30 and ask any questions you want about the rock cycle. Now, next week, we'll be talking a little bit about the different rock types and how you can identify them. Until then, we'll see you later and enjoy.